We are moving on to chapter 11. We're getting up there in the chapter numbers. Now, chapter 11 is all about measurement. And units of measures. So, when I'm using numbers to represent actual quantities, those numbers don't mean anything unless I attach some unit of measurement. If I say, yesterday I ran 10, that has no meaning. If I don't say 10 what? For 10 minutes? 10 kilometers? Some of those statements are more impressive than others, if at all. It has no meaning until I attach a unit of measurement to that number. Then it has meaning. So our goal is to just be aware of the common units of measurement, maybe some you don't use often, and to be able to convert between them comfortably. So how these things developed over time is unfortunately not the most efficient way possible. And we still have today the English or imperial system that sort of developed over time based on the needs at that time. You have the concept of a mile to measure longer distances. And then the mile unit isn't very appropriate if I want to measure the width of this room, for example. So then we have a yard, and 1 mile is approximately 1,760 yards. Why? I don't really know. So the downside, the drawback of the imperial system is the conversions are not obvious. And they just sort of developed over time to be what they are today. A smaller unit is a foot, and a common conversion, I think most people know. Again, these aren't perfectly accurate, but they don't need to be for our purposes to just get the concept. 1 yard is approximately 3 feet. I know these aren't perfectly accurate, but they sort of got refined and more accurate as time goes on. So we just want to have a rough conversion, an idea of how these units relate to each other. And then if I go even smaller, where the yard and the foot measurement may not be convenient, I have an inch, where 1 foot is equivalent to approximately 12 inches. So let's first see how we would convert between these units. So our goal is twofold. Our goal is, first of all, to be able to convert between units, and also to do it in a way that can be taught to someone else. Do it in a, let's say, a sensible way. Not just scribbles for me to figure out the answer, but in a way that the presentation can be used to explain it to someone else and teach them. So there's a balance between the two for us. So let's look at exercise 11.2 first. And I'll give you some options with varying degrees of detail. But if you already know how to convert between units, then I'm not expecting you to change what you are comfortable with at all. If it makes sense to you and it's a way it's done in a way that you understand and can explain it to someone else, totally fine. I am just giving you some options in case you have no idea. So our goal is to convert 50 feet to a certain number of yards. Now, we are not expected to memorize these conversions. I have to use whatever conversion table is given. So let's suppose that one is given. I have to use only that. If I perhaps know of another conversion, maybe I, from past experience, know the mile to foot conversion already. If it's not on the table, I cannot use it on the quiz, so that no one has an advantage. In this case, we want to go feet to yards. So I'll do the detailed version first, which is overkill. But if I really have to explain it, this is my last resort with the most detail. So if you remember if you've done Math 142, you would remember that we did ratio equations, which also concern unit conversions. So what I do there is I have a reference pair, I call it. And in this case, we want to go between feet and yards. And I know that 1 yard is equivalent, according to the table, to 3 feet. So 1 yard will correspond to 3 feet. Regardless of if it's perfectly accurate or it's the conversion that you know or that Google confirms or whatever, I use whatever the table gives me. I don't want to have all the decimals of accuracy because it just distracts me from what we are focusing on. Then, am I reading the question right? Yes. 1 yard, 3 feet. I want to know how many yards will correspond to 50 feet. So I put my little divider lines there, put an equal sign in the middle, get rid of the arrows. Does this look familiar to some of you? Maybe you blocked it out. Totally fine. And I have what we call a ratio equation with my unknown question mark sitting somewhere in there. Doesn't really matter where. Whenever I have this equation, I convert back to pen, cross multiply. So 3 times question mark will equal 1 times 50. And so question mark equals the right-hand side divided by 3. And then I can plug that into my calculator and get an answer. For our purposes, rounding to 2 decimal places is more than sufficient. But if my answer has some decimals, don't just throw them away. What do we get if we say 50 divided by 3, rounded to 2 decimal places? So I get 16.6 repeating, which means I'll do it like this. 6, and this guy is more than 5, or not more than 5, 5 or more. Right? The letter 5 or more, because it's another 6, which means this gets updated by 1 to 16.67. If you're not going to write the answer as accurately as possible, you need to make sure that you are rounding correctly. So let me know if you're not sure, you don't remember rounding, you're not sure as we go and practice more. Don't just drop the decimals. If they are 5 or more, then we have to update the last decimal by 1. So this will then be in yards. So 50 feet, 16.67 yards approximately, using the table. So this is now the detailed version, going to an unknown question mark, setting up an equation, perfectly clear, given you're okay with equations. But you'll see, for a fairly straightforward conversion like this, which has a reference pair on my table, it might be overkill to set up an equation and call the variable something. It's a little overkill. So the shorter way of doing the same thing, and I'm just giving you options. Maybe you have something that looks very different. Please let me know. Maybe there is something even more efficient, while not giving up too much understanding or clarity in how I present it. Here's another option. So I want to go, I'm starting with 50 feet, right? I'm going to multiply that with my, what I call reference pair that comes from the table, and that would be 1 yard corresponds to 3 feet, so that I end up with my desired unit yards. So I know it's going to be 1 yard corresponding to 3 feet. I just need to put the yards and the feet in the right position. I'm going to put feet in the bottom and yards in the top, so that if I just look at the units as if they are numbers, this is over 1. So there's a feet in the numerator that cancels with a feet in the denominator, and the yards are left, which is what my goal is. So that tells me which way to put the reference pair. I know from the table which reference pair I'm going to use. It's just a matter of which way to put it. And the units have to cancel as if they're numbers as well. We do this in physics and things like that often. So then I still get 50. I'll confirm 50 times 1 over 3 is the exact same calculation as before. Because we haven't done anything different. There's different options in how to present your answer. Any questions on the two options that I've mentioned? Again, if you have something else that you understand and makes sense and makes sense on paper as well, it's totally fine. I don't want you to feel the need to change what you are already comfortable with. But I feel this version is a nice middle ground. It does show what I'm doing and the reference pairs I'm using, and then what the calculation is, keeping track of the units, while not setting up a whole equation either. But again, it's just a suggestion. Let's see if we have space. We don't really have space. Let's go and make a new page for number 2. Let's see, what do we have to convert? Number 2. Now it's just a matter of whatever method you're settling on, practicing that enough so that you are comfortable with how you are going to do it. So whatever method you pick for how to lay it out and answer and figure it out, just always do that so that you can get that consistency. So I want to go from yards to inches eventually. But if I look at my given table, there is no direct yard to inches conversion. And I'm going to be restricted by the table. So I have to make a plan for how to get from yards to inches, and I'm going to do it by going to feet first and then to inches. So we need to make that plan first. First I'm going to go and use the yard to feet conversion, where 1 yard corresponds to 3 feet according to the table. Then I'm going to be in feet. So then I'm going to go feet to inches, where 1 foot corresponds to 12 inches, and then I'll be in my desired unit. So the reference pair that I have to use first needs to be positioned so that yards are in the bottom, feet in the top, because it needs to cancel the current yard unit. And that means it has to go this way. So the yards cancel, and I'm currently in feet. That means I need to put the feet in the bottom and the inches at the top for the next conversion, which will put the 1 in the bottom and the 12 at the top. The feet cancel, and I'm in my correct inches unit. Then the numbers are just put together, 2 times 3 divided by 1, but I don't need to actually put that in because it's a 1 times 12, so I get 72. And again, write enough so that you understand what you're doing. For some, that could be less than this. For others, you may need to write more than this. I can't necessarily tell you what you need as long as you understand how to get the conversion answer. Yes.
Isn't it more simple just to do like 12 inches in a foot and then
so
12 times 3?
I should have said, if you look at the book, those tables are not the ones you are going to see in the test. They need updating. This is what you're going to see in the test. Which means I need to, and the question is going to specifically say, use the conversions in the table to show how you would find the answer. And the book ones that are currently in there don't look quite the same. If the book gives you something more direct, you can totally do that.
So like the previous question, I just did 50 divided by 3.
Yes.
Would that be
Of
incorrect?
course, that's correct.
Yeah, okay.
No.
So you can do it however.
That satisfies the first goal. And for a quiz, totally fine. No problem at all. Where's my goal? That perfectly satisfies the first goal. The problem is, to many people, especially little Timmy, it's not obvious why you divide.
Right, okay. Gotcha.
Because it's brand new. It's strange. You develop that level of comfort and understanding. So as long as you have a backup to be able to explain it, if you have to explain it, someone doesn't understand, how do you know just to divide? You just magically know? No, well, I can explain it. So we always have that second goal in mind, but for a quiz, it's not crucial. But for our intended career path, it's very crucial. And not every quiz question tests that explanation part. Because first, we have to be able to do it before we can even bother with the second goal. So in an attempt to have them both, we're going to be restricted to a table like that. And a part of the answer should be showing how you use that table, not some other conversion that's not on there. Just to try and get both of those goals and see if we are good on both. Any other questions? Where's my answer? This is just one way, not the only way. But a way, I have to sort of show a little bit more so that in case you're not sure, it's explaining it a little bit as well. Any thoughts so far? Some are very comfortable with unit conversions, some never do it. So we just want to get everyone up to a certain level of competence. The next page, 81, I have number 3 there, where I have to convert 235 inches to miles. So I need to make a plan first. Inches to miles. Oh dear. That's going to go all the way through everything in my table. That's good practice. It's certainly not the most efficient, and I can certainly, in practice, use Google to look up a short conversion, if not, just ask it directly what to do. But that doesn't really make me any better. Inches all the way. So I'm going to make a plan. My first is to convert inches to feet. And I don't have to write it at the bottom. I just have to put the inches and the feet in the right position. 1 foot, 12 inches. Inches has to be in the bottom because the inch unit needs to cancel. So currently I'm in feet. Then I need to go feet to yards. And I'll put feet in the appropriate position so that they cancel, and currently I'm in yards. If I were to do the calculation, 1 yard, 3 feet according to the table. And lastly, yard to miles. And according to the table, we don't have to memorize that. It's going to be given 1 mile, 1,760 yards. I know in the book it's different. I'm updating it to be how we will see it in the quiz. So now the yards cancel as well, and I'm in my correct unit that the question wants. So is it the most efficient? No, but given the table and my restriction, yeah. I'm restricted by the table that's given, and those tables, these ones, are the ones that you will see, regardless of what's currently in the book. I will type this up and hand it out tomorrow so that you can insert that. And remember, not look at the book's tables, but look at these instead. Oh, let me go back to the answer. Any thoughts on that one? Yes?
So to put that in my calculator, I would do 235 times 112 times 103 times. Then how would I
Yeah.
calculate it? Okay.
The 235 is the first number.
Yeah.
You can say times 1 divided by 12, but because it's 1, you don't have to. So to be more efficient, you can drop all the 1s and say 235 divided by 12, divided by 3, divided by 1760.
Okay.
The units will always have a 1 somewhere, which you can ignore. And what do we get then? Yeah.
0.0037.
0.0037. Not a lot of inches. My mile unit is pretty big, so not a lot of miles. So once I've set it up, keeping track of the units, the rest is just calculating whatever it says to calculate. Yes?
In that one, because you said you're around 2 decimals.
2 significant decimals, so the zeros don't count. Yes, I should have clarified. The first non-zero one is where it starts. So I can have like 10 zeros and then something not zero, the first 2 of those. All right, now as much fun as it is to work in yards and feet and everything, people soon realized, well, some people, that it's not the most efficient way it could be. I mean, these numbers developed as the need was there, and they didn't really think their system through completely. And people realized, well, our number system is a decimal system. Shouldn't our conversions be based in tens as well? That'd be way more efficient. So, luckily they did that, and the international standard system is pretty much used by everyone, but there are still some cultural ties to the imperial system. It's hard to change when you're used to one thing and you have an intuition of how long a mile and a yard is. It's hard to change. But this system uses only powers of 10 and is therefore more in line with our number system, which isn't powers of 10. So some of those will obviously be familiar. The kilometer is 1,000 meters. So these ones are, where's my pen? These ones are the familiar ones. And then you can also go smaller. And I'm going to print this out, type it up, print it out. So you know exactly what the quiz one will look like. But there are also other ones, taking steps of 10 every time between a kilometer and a meter. 10 meters makes 1 decameter, deca meaning 10. 10 decameters make 10 hectometers, and then 10 hectometers make a kilometer, giving me that 1,000 meters in a kilometer, 10 times 10 times 10. But because the jump from a unit size 1 to 1,000 isn't that big for practical use, we don't really have common uses for a hectometer and a decameter. which is why they're not very familiar. We don't really mind jumping from 1 to 1,000. That's an okay jump to make. We don't need to only have jumps of 10. But technically, every jump of 10 has a unit. Then if you go smaller, we have a decimeter and the more familiar centimeter and millimeter, jumping size 10 as well, where 1 meter is 10 decimeters, 1 decimeter is 10 centimeters, 1 centimeter is 10 millimeters. But because we don't need that many jumps, the more familiar 1 meter is 100 centimeters and 1,000 millimeters is perfectly fine to use. So you don't have to worry about things that are not in the box. The box ones are the ones that we will be given and that we can use. And you don't have to memorize them if you don't know them already. They'll always be given in a table. We just have to know how to use them. Because there are many other units, other types of measurement, and you don't need to know them all. But many of these will be familiar. Any thoughts on that? So now, just to practice and see how they work, we will go to exercise 11.1. My approach doesn't need to change. I need to convert 50 meters into kilometers. So I'm going to have my reference pair. Looking at my table, I have kilometers and meters as the second one in the first box. I just need to position the meter unit at the bottom and the kilometers at the top. 1 kilometer, 1,000 meters. And that is going to cancel the meter unit and make sure I'm in the right unit. And then the calculation follows from that setup. Just like in the ratio equation detailed method, I set up the equation and the calculation comes from whatever the equation is. I don't think about the calculation first. I set things up, and then the calculation is what it is. And that takes away the pressure of knowing, do I divide? Do I multiply? When do I know which one to do? I don't care. I set it up, and then the calculation is whatever it is. There's no guessing, there's no intuition, there's no magic that I have to know when to divide, when to multiply, by how much. I don't care. I give it no thought whatsoever. This setup tells me I divide 50 divided by 100. And there's nothing to do. Well, not nothing, but there's no significant thinking to do. So if we focus on the setup, whether it's a full ratio equation, whether it's like this or some other version that you might be comfortable with, the setup comes first, the calculation follows that. People are too obsessed with calculations. The second one, 2 meters into centimeters. So I know I need to be in centimeters eventually. So do I have a conversion directly? Meters to centimeters, yes I do. And these are just much easier to remember. Meters in the bottom, centimeters at the top. 1 meter, 100 centimeters. This then tells me I need to multiply this time. I didn't need to think about it until now. I'm just setting it up. Now, I will admit the 2 meters sitting this low may make some of you uncomfortable. It's actually up there, right? I don't know. It was a little too low, perhaps. And because anything, if I make it a fraction, I put it over 1, that initial amount is at the top in the numerator. So it cancels with the bottom. That tells me it's 200, nothing to think about. Last one, 5 millimeters into decimeters. So now I don't have to memorize these. I look at my table. Do I have a millimeter decimeter conversion? According to the table, no. I'm going to have to go through centimeters to get to decimeters. If I have to just stick to the table. So I was a little premature here. That's not a big deal. I'll go to centimeters first. Pen, not eraser. There you go. Which means I'm going to go millimeters at the bottom to cancel my current millimeters, centimeters at the top. 1 centimeter, 10 millimeters. Now I'm currently in centimeters. So I'm going to go centimeters to decimeters. 1 decimeter, 10 centimeters. And it then gives me the calculation that is maybe obvious to some, that I divide by 100. But again, I didn't need to know. Of course you divide by 100. I just see it magically in the air. I don't need to know. I don't care. The setup tells me. If I keep track of the units, the calculation comes out of that. And that takes the mystery out of it completely. If I know how to how to travel through the units, the calculation follows whatever I do. There's no need to think about the calculation. Any thoughts or questions on that? Yes?
So, if the one's on the bottom, then you multiply it, and if the one's on the top, then you divide?
Yes, because the fraction matches division. The denominator in the fraction corresponds to division. Yes, but I look at the units to know which one goes where. Anything in the top gets multiplied, anything in the bottom gets divided. We can do it all in one and then do the division, or just multiply, divide, multiply, divide. It's up to you. Then, the more interesting thought that I know everyone is having right now, can we mix these two? You need to communicate with someone using a different system. You need to be able to convert back and forth between these two. Now, the two links between these two systems that might be the most well-known, and again, I'm approximating, is 1 inch is approximately 2.5 centimeters. If you look it up more precisely, it's 2.54, but I think many people just memorize 2.5 because it's easier. Who here, just out of curiosity, I'm just curious, there's no wrong answer, who knew already 1 inch is 2.5 centimeters? Some, see? Who knew it's 2.54 centimeters? If you do a rough conversion, you don't need the 4, right? You just remember the easier one. But whatever is given in the table, you should use. Just like 1 mile, I remember it as 1.6. It's not really 1.6. It's 1.60934. We don't need those decimals if we are just trying to get a sense of how these units relate to each other. So I want to make it as easy as possible, but I understand that it's not the perfectly accurate numbers. It's good enough for our purposes. So if I'm working with larger units, I might use the second one. Smaller units, I might use the first one, but it's the link between the two. So if we now go to, check my space, I have spaces. Exercise 11.3, making things a little bit more interesting. 50 feet, I want to convert to a number of meters. So I might need to make a plan first, and I'm restricted to the table. But in reality, I don't know the conversion of feet to meters. I don't know. I haven't bothered to memorize it. It just doesn't happen enough. But the mile kilometer and the inch centimeter conversion, that comes up a fair bit to the point where I have memorized things. I just need to make a plan. So how can I do it? I'm going to have to go feet to inches, inches to centimeters, centimeters to meters, based on the table that I have. Right? I'm sort of stuck with this. I can go feet to inches. I can then connect the two systems with the inch to centimeters and then centimeters to meters. Everyone happy with that plan? It's not that bad. That's how I have to do it if I don't have Google. I know, and it's going to be probably the hardest question you're going to have in your class one day is to justify doing anything without technology and the shortcut it provides. I don't have an answer to that. Karma is gonna get you. One day little Timmy is gonna tell you, but why do I need to learn multiplication or addition? I could just ask Google. That's a tough one. I don't know the answer. I think the response is different depending on the person you're dealing with, but they will honestly not see why they need to learn anything. Because Google is an actual person. I don't know. That's a tough question. I don't know the answer. So I can't answer you just like you're not going to be able to answer the thing. In a way that he's going to be okay with. You can answer it, but he's not going to like it or agree with you at all. And it just gets worse and worse. I don't know. Don't know. That's the tough one. Anyway, I can say you have to do it this way because it's on the quiz. But little Timmy will soon realize that he's not going to fail regardless of what he does. So that's not even going to work. So I don't know. Don't know what to tell you. I have my plan. Now I'm going to do my slightly condensed version because it still keeps track of the units and shows enough work. So feet to inches. So according to this, feet has to be in the bottom, inches at the top, 1 foot, 12 inches. So currently I'm in inches, which was my plan. Then I'm gonna have to put inches at the bottom, centimeters at the top, and it's gonna be my, according to the table, 1 and 2.5 conversion, just for convenience. That means I'm currently in inches. Now one more step. Putting centimeters, I'm currently in centimeters. Putting centimeters at the bottom, meters at the top, so that I'm in the right meter unit. And 1 meter, 100 centimeters. That then tells me the calculation is what it is. And in this case, the calculation is 50 times 12. We don't have to divide by 1 because it's 1. So you can really ignore all the 1s. And say 50 times 12 times 2.5 divided by 100, and it is what it is. The setup tells me what to do. What is it? 15? Oh, that's nice. 15. I'm not sure why exactly people are always obsessed with the calculation when that's not the first thing that ever happens. It's never the first thing. Set it up. It can't be the first. Set it up, and then the calculation follows your setup. And there's no reason to think about what the calculation is. How do I know what to do with the 12? How do I know what to do with the 2.5?
I just don't think our teachers taught us this way.
I'm honestly trying to remember, not because I'm old, but I can't remember what we did in school at all.
This seems a lot more simple than what we were taught.
Does anyone remember? I don't remember.
I think they might have the math.
Yeah.
Excellent.
I don't remember ever doing it, to be honest. What grade would this be? It could be fairly early. 5, I could see 5. Depends if they're up to speed. But the arithmetic, you can make fairly easy, yeah. If they don't have calculators, the arithmetic will slow them down a little bit. But the setup, you don't have to do that many steps. But yeah, it's not a complicated thing. But no, I don't know what they do in school anymore. It's very teacher dependent, like almost everything. Yeah. And the sad truth, like many other things in math, is that you as a teacher don't really understand how to convert. What are you going to do in the classroom? I'm just going to do that as fast as possible, if at all. Because if Timmy asks me any sort of question, I don't know what to say. So I'm just going to quickly do it. I think that's what happens, unfortunately. When it's really not hard. No, there's no need for it to be hard, like most things. If you have the method to rely on, then everything just follows from that. And there's no need to worry about what the numbers should do. Ooh. Do I have space? Sure, why not? That one is asking for the less familiar decameter, because why not, into yards. Just need to make a plan. Now, I can definitely go decameter to meter. That would be a good plan. Can I go to centimeter directly? Or should I go up to kilometer? Maybe, yeah, let's maybe do that. Yeah. So I'll go up to kilometer. Then go miles, because miles has a direct conversion to yards. Mm-hmm. Beautiful. So there's a little bit of problem solving as well. What's the shortest path? I like it. And then once I have my plan, I lay it out, because I've decided on this method. It works for me. So I need to put decameter at the bottom, kilometers at the top. 1 kilometer, maybe I don't know. I don't remember. Let's go look it up. You don't have to memorize any of these. It's 100. See, you don't want to guess. Go look it up. You don't have to remember any of it. The table will be given. So now I'm currently in kilometers, which means I want to go the kilometer to mile conversion. And we'll just use the easy 1 mile, 1.6 kilometers. Even though we're losing some accuracy, there's no harm in that at our level. So currently I'm in miles, and then I need to convert miles to yards so that the miles cancel, and I'm in my correct unit. And the conversion there is 1 mile. After a while, you sort of remember this one, but you can always look it up. Don't have to memorize a thing, it's right there. And then the calculation is what it is. I never thought about the calculation until now. 2 divided by 100 divided by 1.6 times 1760, and it is what it is. I don't know what it is. 20 point? Nothing? Oh, surely there's something.
No decimal.
Oh, no decimal, perfect. Even better. So of course, it's not exactly 22 yards because it's not exactly 1 mile to 1.6 kilometers, but we're so close. There's no need to worry about anything outside of the table that is given to you. Piece of cake. No? Could be. Settle on your method and don't change your method. Be consistent. That consistency builds confidence and all those good things. We have 2 more. Why not just squeeze them in and be done? Because all it is now, I've settled on my method. I just need to practice. So, 200. Oh, that's a super easy one.
The next one's easy too.
I'm a little insulted. 235 kilometers to miles. I'm just going to do it right away. Aw, I was hoping for something even worse. They were obviously in the wrong order. Oh well, makes me feel better. Why not? Again, I set it up and the calculation comes from that. I didn't need to know beforehand. Do I multiply? Do I divide? I know there's a 1.6 in there. I don't know. I set it up, keep track of the units, and the calculation says divide, so I divide. Yes, the more you do this, you develop sort of an intuition. I don't want to call it intuition. sort of an educated guessing, but there's no need for that. 235 divided by 1.6. 28? Oh, right. Perfect. Easy. And not for a second did I wonder, should I divide by 1.6? Should I multiply? It never occurred to me. It was never a stumbling block or anything.
So why wouldn't you just round to the right and place this part better?
No, we just, there's no rounding that has any preference. You could round to the nearest mile. We just make a decision. I like some decimals, just in case you need to use that in some other calculation. You weren't too aggressive, but no reason whatsoever. You can totally round to 1. Doesn't matter. And in the quiz, in the final, I'll probably just look the other way, because there's no reason why. Well, apparently the next one's easy too. All good news. It's super easy, wow. 5.23 centimeters, 2 inches, so I have only one step, and I'll use my 1 inch 2.5 conversion because it's convenient and in line with what I remember. And that tells me centimeters cancel, I'm in the right unit, perfect. It tells me to divide. So I do. I mean, you do. 2.09. You could have said 2.1. We just make a decision to practice rounding. We have a chance to practice some rounding. Remember that, so why not?
Please remember to click the like button if you enjoyed the video, and to subscribe if you want to be notified of more videos. Thank you.